what they should be studying. And what I would recommend that you study for the S1, there's a California State Sacramento, or CSUS, they go by for short, course called a distribution operation and maintenance. And that's a book that has some very good calculations for like what you would see on an S1 and S2 type exam. And the rest of the material is also very good for reviewing for the other subjects that are on the exam. It's not to say that this math class won't cover some of what you're going to see on the S1. Obviously it will, with continuity equation and chlorine calculations and stuff along that lines. There will be some of those on your exam also. But you had asked yesterday, I don't remember who exactly it was, but someone had asked, and I figured I would clear that up. So today we'll be doing areas and volumes and an introduction to flow rates. The reason there's an introduction to flow rates is because tomorrow we're going to be dealing with the continuity equation along with static pressure hydraulics. And I want to introduce the subject to you because we've already dealt with some flow rates. Maybe some of you've realized this, maybe some of you haven't, but it's just kind of a reinforcement to that. So with that being said, I will go ahead and let Matt run the first poll question, and then we'll get class underway.
All right, thanks, Scott. So this first poll question, pretty typical. We ask this at all of our webinars, and we just want to know how many people are viewing this webinar at your location. So if you take a moment to answer this, already up to over 80%. So it looks like you guys are doing really well with the transition from GoToWebinar to Zoom. So just a few more people. We're up over 92%, 49. Let's close this out with a completed poll. If you do not need CECs, you can ignore these polls. So looks like 49 out of 52 have responded. And if you're having issues with the poll, feel free to drop a comment in your questions dialog box, and so that just will line up, and we will know if you are having an issue with the poll question. Yes, so I just got a question here on the PDF for this course, and I will drop that into the chat right after I close this poll. All right, I'm going to go ahead and close the poll.
All right, with that being done, all right, let's go ahead and move on to the very first things, okay? So I know the very first thing you're going to see here is going to be unit and conversions, okay? And the reason that we're doing this is to reinforce unit conversions, because unit conversions is really important. You know, I stressed it yesterday, that is absolutely the most important part of the math that we're going to be covering, is that you understand how to convert units and how to do it properly, right? So we're going to be doing a couple more pages of this today. Not all of these, obviously. All of these will be, these ones will be like homework, but we're going to do a couple pages here of unit conversions, again, to kind of reintroduce them to you, or bring them back, because repetition is what helps with unit conversions and understanding how it works. And then we'll move into areas, volumes, and then flow rates, right? So here on the very first page, what I will do is I'll walk through a couple of these and I'll give you guys some time. And then same with the page on page 22 here behind this. So convert 400 gallons of water to cubic feet. So again, you're going to have to start with what you're starting with. You write that first. So I'm starting with 400 gallons of water. If you recall, the third rule of fractions is that everything is over 1. Everything is assumed to be over 1. So 400 over 1. Well, I need to get it to cubic feet, and I know that 1 cubic foot equals 7.48 gallons. So you can see here's my bridge between the two factors here. If my gallons are up top here, where do they need to be to cancel? So if gallons are on top, they need to be on the bottom to cancel. So 7.48 gallons here. And then 7.48 gallons equals 1 cubic foot. So that's what goes with it, above it on the fraction. So I multiply everything this way and everything this way on top and bottom. I got 400 times 1 is 400. And then I have 1 times 7.48 is 7.48 here. And then when I do that, my 7.48, and I got an answer of 53.475, as you can see here. So I'm going to round that to 53.48 cubic feet. You can see second decimal, the third, we want to go to the second. So we're at the third here and we're going to round up. So 53.48. All right. 90 gallons of water into pounds. So it's 290 gallons is what I'm starting with. It's over 1. Well, I know that 1 gallon of water equals 8.34 pounds. So if gallons are up top, where do they got to be to cancel? They're on top. They have to be on the bottom to cancel. 1 gallon equals 8.34 pounds. Goes up here. So 290 times 8.34 gives me 2,418.6 pounds of H2O. It doesn't take a lot of water to equal a lot of weight. Water is 8.34 pounds per gallon, so it can get heavy pretty quick. All right. So I am going to let you, we're going to skip to page 22 real quick here. And I will go over this one real quick. Convert 9 cubic feet per second to gallons per minute. And then I'm going to let you guys work on these for 7 or 8 minutes, and then we'll go over them. All right. So this one, if you recall, is different than what we were just doing. This one has 2 units to it. I mean, it's 9 cubic feet. Do you remember what the per is? The per is the fraction bar that splits the units. And then 1 second goes below here. Remember, per is the fraction bar. Per is the fraction bar. Okay. So I need to get cubic feet to gallons. Well, I know that 1 cubic foot equals 7.48 gallons. And then I need to get seconds to minutes. And I know that 1 minute equals 60 seconds. So does it matter if I convert top or bottom unit first? Because if you look, I mean, we know we got to convert both seconds and minutes here. They don't match. Cubic feet to gallons, they don't match. So I got to convert both. It does not matter, if you recall, it does not matter if we convert the top or the bottom unit first. So we're going to go ahead and do the bottom unit first. If seconds are on bottom here, where do they got to be to cancel? They're on the bottom, so seconds have to be on the top. Well, down here, my conversion factor has 60 seconds, so the seconds have to be on top. Imagine 60 goes there, and the only thing it can ever go with 60 seconds is what it equals. So what does it equal? 1 minute. So seconds like that cancels. If cubic feet are on top, where do they have to be to cancel? So cubic feet are on top, where do they got to be to cancel? They got to be on the bottom. So put 1 cubic foot there. 1 cubic foot equals 7.48 gallons. And I'm going to go ahead and do the math. And this equals 4,039.2 gallons per minute. Okay, with those as a refresher, I want you to go back to page 21, number 3, A, B, and then number 4. I'm going to give you guys about 8 minutes to work on these, to go through these, and then we'll go through them, okay, before we move on. So I'm going to give you 8 minutes to try these on your own, and then we will go over these together. It's been about 7, 8-ish minutes for this. So let's go ahead and go over these before we move on. All right, a tank has a capacity of 77,000 cubic feet. What is the gallon capacity of the tank in gallons? So I'm starting with 77,000 cubic feet. It is over 1. Well, I know that 1 cubic foot equals 7.48 gallons. So cubic feet are on top, cubic feet have to be on the bottom. 7.48 gallons up here. Answer for that is cubic feet cancel. Using it just gallons. 5,700 or 575,960 gallons. How many pounds does the water weigh in the tank? So that's assuming that the tank is full. Stupid white box over there. All right. I would be starting with 575,960 gallons. That's over 1, but I know that 1 gallon of water equals 8.34 pounds. So if gallons are on the top, where would they have to be to cancel? Well, down here, 1 gallon with 8.34 pounds up here. Excuse me, 4,803,506.4 pounds. All right, so you can see here that to get cubic feet to pounds, we had to convert to gallons first and then gallons to pounds, right? What happens if we could do this in one step? As in one equation. So I'm starting with 45 cubic feet, it's over 1. Well, I want to know how much this water weighs, so I could do the 1 cubic foot, 7.48 gallons, which will leave me with gallons. Well, if gallons are up top, where do they got to be to cancel? Down below, 8.34 pounds up there. So you can see now that we're at, instead of, 1, 2 steps, but it was an A and B question here, that we can do it like this. We're using that. All right. And when I do this, I get 2,807.24 pounds. All right, so that's that one. Okay, now we have 6, 7, or 5, 6, and 8 to do on this one. All right, so I have 650 feet per minute. Now look at this, I got feet and feet, and I got minute and seconds. So I need to get minutes to seconds, and I know that 1 minute equals 60 seconds. So if my minutes are on bottom, where do they have to be to cancel? From bottom here, they must be on the top to cancel, which is right here. Put 60 seconds here. That cancels feet per second. So 650 divided by 60. So 10.83 feet per second. I better double check that. Yeah, 10.83. All right. Now on the next one here, I have 700 gallons per minute. I need to get this to, it says gallons per minute to GPD, which is gallons per day. So say gallons per day. with knowing that I don't not have to convert the gallons unit because it's gallons in both, but I do have to convert minutes to days. Well, I know that minutes to days, I got to work up, making my units larger or the bigger measurements, right? So I know that there's 60 minutes equals 1 hour. Well, what comes after hours to days? 24 hours equals 1 day. Kind of like that. So if my minutes are on the bottom, where do my minutes need to be to cancel? Up here. And how many? Well, 60. What goes below that? 1 hour. If hours are on bottom, where do they got to be to cancel? Here. So 24 hours, 1 day. Hours are canceled and just multiply across top here because there's nothing here on the bottom to divide by. Oh, that's not right. There we go. So 1,008,000 gallons per day. All right. So that's number 5 and 6. And then we have number 8. All right. Number 8's down here at the bottom. So I have 600 gallons per minute. And I got to get the cubic feet per second. So I need to know my conversion factor for cubic feet in gallons. 1 cubic foot equals 7.48 gallons. And then minutes to seconds. So I know that 1 minute equals 60 seconds. Gallons, cubic feet, and minutes to seconds. You see, gallons, cubic feet, minutes, seconds. You can see our conversion factors there. So if my gallons are on top, where would they have to be to cancel? On the bottom, well, 7.48 and 1 cubic foot up top. And then if I have 1 minute on the bottom, okay, gallons cancel. So if 1 minute's on the bottom, where does it got to be to cancel? Means minutes has to be up here, and it's 1 over 60 seconds. Minute. 600 times 1 times 1 is 600. Well, 1 times 7.48 times 60, everything across the bottom this way, is 448.8. Which comes to 1.34 cubic feet per second. All right, so with that being said, I want to turn to page 25, okay, which is the calculation of areas. So here we're going to be starting to talk about, yeah, it's page 25 at the bottom of the handouts here. We're going to be starting to talk about areas, okay, and why they're significant and what ones are we going to be dealing with. Okay, so areas may seem something that are not significant, but I'm going to tell you, if you're a treatment operator, areas are very significant to you, especially when talking about filtration rates and backwash rates and so on and so forth. And areas also set the table for us when talking about the area of like surface recharge area, the source waters. You start thinking about protection areas of municipal wells, and then other things along the lines of helping with solving for volume, okay? Because the area formulas are the foundation for your volume formulas. So how do we recognize the measurements of areas versus the areas of like volumes or anything else? So I have yet to meet an operator, if I gave them a measuring tape, could not tell me the area of the room they're within. Like whatever room you guys are all sitting in, you could tell me the area of where you're at. So what I'm dealing with, and what I mean by that is, we're looking for measurements in order to solve for them. And the measurements that you often see are like square feet, square inches, meters squared, centimeters squared. What do these all have in common? Could you guess? These all have a square unit in them as common. So what does that mean? So we'll take feet squared, for instance. What square feet means is it means that it's times itself twice, kind of like this. So we have square feet times, or we have feet times feet gives you square feet. The square means times itself twice, okay? I want to just get that out there and make that abundantly clear. That the square just means times itself twice. So that leads us to our very first example here. A area of a rectangle, which most of the rooms that we're probably in are rectangular, right? It isn't very often you see a circle room or a triangle shaped room, but it's mostly rectangular rooms. So in the area of a rectangle, it is literally length times the width, okay? One thing to bear in mind here is that units must all be the same. All right. If you're going to be doing an area calculation, your units must all be the same. Meaning this couldn't be, 180 inches long and the other side be 10 feet. You can't multiply those together because you won't get a similar unit. Meaning they won't be feet squared or inches squared or anything like that. So they all must be the same, meaning if they're not, you have to convert them. And I will tell you, the common units that we're going to be using per area are square feet. And there's a reason I, brought that example out. So here in the very first thing of a rectangle, we're looking for the area that is 34 feet by 22 feet. So how would we solve for that? Well, pretty straightforward. It is length times width, so it's 34 times 22. And it's feet, so it's going to give me 748 feet squared. So the fact that you have 1 feet and 2 feet here in the multiplication, that's where you get your square feet. Like I said, multiplied by itself twice, okay? So if you see a square, it's often an area, and square feet is the area that we choose to use for this. Okay, the area of a square, if I don't do this, it doesn't go away. There we go. So the square area of a square is pretty straightforward. This is one thing that I'm pretty sure we all know, and I don't have to really stress too much. If I tell you one side is 13 foot long, how would you solve for the area of a square if I told you one side is 13 foot long? Well, it's a square, so all the sides are equal length, so it would be 13 times 13, which comes out to, I don't know, that's what I thought, 169 square feet. All right. Does that make sense to everybody? I hope so. All right. So the next thing we need to talk about is a circle. So a circle is a curved shape where all the measurements from the center point are equal to each other, okay? Or which would be known as a radius, okay? So first off, I want to, we're gonna make things a little bit easier on ourselves. We're gonna cross this off and cross that off. And then we're gonna change this question to a diameter of 20 inches, okay? So you're probably asking me, why are we doing that? Okay, so first off, Probably 70% of you in here are distribution operators. I mean, I don't know the exact breakdown, but that's just my guess because that's usually the status pro quo. Most of us are distribution operators, or even if you're not, most of us deal with diameter when we're talking about anything in the water industry, right? So like if I tell you that me and John Smith are going to go out and replace an 8-inch water main. So if this is our water main, we're going to go fix because it's got a break in it here and it's, squirting out water. If we're going to go out and replace this and it's an 8-inch, am I referring to an actual 8-inch main, which is, is about the diameter of this paper here? Or am I talking about a 16-inch, which would be 2 of these papers, right? We're talking about an 8-inch main, right? Everything that we deal with in the water industry, for the most part, is diameter, right? Some of you guys have clarifiers at your plant possibly, and I might say that your clarifier has a diameter of 100 foot across or something, right? Some of them are really big depending on what water plant you're in. So the thing about it is we deal with diameters, the drum, it's got a diameter of 18 inches across it or 2 foot or something like that. Our catch basin, everything is in diameter. So it's best if we use something that we're familiar with. Well, okay, that's all fine and dandy, but what's the area formula for cylinder or a circle, more or less? What's the area for a circle using diameter? So area for a circle using diameter is 0.785 times diameter squared, which if you remember is 0.785 times diameter is what that means. Okay, now that we know that, I want to, where does this come from? Well, let me explain. Some of you may have younger kids. Mine is now 7, so she's past this point by a lot. But maybe you have grandkids. Maybe you have, a couple 1 or 2-year-olds in your family, and that's a horrible square. But you recall the old toy where it has round holes and square holes and triangle holes and all these different shapes, right? For the kids to learn shapes. And if you recall, the square peg never fit into the round hole, but the round peg always fit in the square hole, no problem, no questions asked. So my question to you is, if we put that circle into that square like we did, you can see that it doesn't fill up the whole thing, right? We have some areas here and here and here and over here. What percent of that square is taken up by that circle? What percent of that square is taken up by that circle? Okay. Well, I'm willing to wager that it is 78.5%. That's where the 0.785 comes from, okay? Is it 78.5% of that circle takes up that square, okay? That's where the 0.785 comes from. So let's go ahead and do that math question here. What is the area of a circle with diameter of 20 inches? So area equals 0.785 times 20 times 20, and that'll give us our answer. So go ahead and do that. And I get 314 inches squared, because remember, this is inch, so we get square inches. 314, and what do we do when we get it as pi? 314, okay? So if you want to use pi r squared, go right ahead, that's fine. But I'm going to tell you that I will use 0.785 exclusively, and it's because it fits our industry better, right? Yes, I'm not out replacing water mains, but I have been in this industry regulating you folks and doing trainings and stuff for the past 10 years. I do have some wastewater experience. That's something that a lot of people are always shocked to find. I have ran plants in Houston, Texas, and in Big Rapids and stuff along those lines. So I do have some wastewater experience. All right. If you are a mathematician or give a care, here is how you mathematically arrive at 0.785 times diameter squared. It can be derived mathematically, as you can see here, or you can just take my word for it and that this is the formula and we're going to use it, okay? All right, so on page 28, a water main has a diameter of 8 inches. Calculate in square feet the cross-sectional area of the main. Okay, so there's a couple things I want to show you here. Okay, I'm going to show you shortcut number 1, and we're also going to talk about what cross-sectional area means. What does cross-sectional area mean? Ask yourself that. I don't think I've ever heard of that. If you've taken geometry, or it's been a long time since you've taken geometry, that's where you would remember it. Cross-sectional geometry means that let's say this is an 8-inch pipe. And at any place here, I could take like a slice of that pipe, right? Which is a cross-section. So cross-sectional area means at any point within a shape, I can just take a slice of it and I want to find the area of it, okay? So basically, it means area of the circle. It just wants to know the area of the circle. Cross-section means just anywhere on that 8-inch pipe, I want to take an area reading of it, okay? So then there's another thing. It says in square feet. So I'm going to give you an always rule. Always convert inches to feet. You divide by 12. So this is something you should always do. But just like any good mathematician, what I tell you, there's always got to be an exception to the rule, correct? So any 3 or 4 level exam, this is 100% okay, and it applies 100% of the time to you. If you are taking especially an S1 or an S2, there is exceptions to this. Always convert inches to feet, okay? So if you don't listen to me now and you get it wrong, it's not my fault because I told you so, okay? Except for dead end pressure and leakage calculations, okay? So on your exam, on S1s and 2, if you see a dead end pressure or a leakage calculation, you do not convert inches to feet, okay? Cannot stress it enough. If you do this, you will get it wrong. I promise you, you will. Because dead end pressures and leakage calculations are based on PSI, which stands for pounds per square inch. So that's why you leave it in inches, okay? Don't say I didn't warn you. But for anyone who's taken a 3 or 4, and for our purposes of this class, we will always convert inches to feet. But I gave you S1 and S2. Do not, on these calculations specifically, do not convert inches to feet. I warned you, okay? So here in this question for this example, 8 inches divided by 12 is going to give me 0.67 feet. So my area for that will be area equals 0.785 times 0.67 times 0.67. All right, so I'll do the math here. 0.67 times 0.67. And that will give me 0.35 square feet. All right. So make sure you have this written down. And those of you taking an S1 or 2, do not forget that rule. The exceptions are for those 2 specific calculations. Not saying they're on the exam every time. Saying if they are and you do it, you'll get them wrong, okay? All right, circumference. So what does circumference mean? So circumference, here's a circle. Circumference is the outside measure around the outside of a circle. Most of you, if you were to be asked to go measure circumference, will get out like the clicky wheel thing that you push and it clicks over a certain amount of distance, and you would just walk around it. But here's the thing. If you know what the diameter of that thing is, you can calculate the circumference by doing 3.14 times by whatever the diameter is. That equals circumference. So circumference will equal like inches or feet or meters or something like that, okay? Just a distance, because all it is, it's an outside measure around the circle here. So one way of easy thinking about this is, you see my paper has a long edge, right? Well, I can fold that up and I have a circle now, right? Kind of like that. The circumference is the outside measure around that. For a piece of paper, what would be my circumference length? Well, these pages of paper, 8.5 by 11, so that means it's 11 inches if I were to perfectly roll this up and like that, touch it together, okay? Circumference is the outside measure around that circle. So you can calculate it though if you know the diameter by pi times diameter, all right? So with that, here on the next page, I'm going to give you 3 questions that I want you to all do, and I'll give you 6 minutes to do these, and then we'll come back together and do them together, okay? So what is the area of a rectangular room with the measurement 32 feet by 42 feet wide? So this is a rectangle, so area equals length times width. So it's 32 times 42 equals 1344 square feet. All right, the standard isolation area of a municipal well is 200 feet in all directions from the well. How many square feet is this? So what we're going to do is we're going to, over here, we're going to have a municipal well. It's 200 feet in all directions. So it's 200 feet this way. Now, if you recall on watching TV shows, you see like the radar swoop, it goes beep, beep as it swings around. Or how about farming, right? So this thing could swing around kind of like, okay, that's a crappy circle, but you get the point. It could go 200 feet this way also, correct? So if it can go 200 feet in both directions, they could do this way 200 feet and this way 200 feet. What's my true diameter of this circle? Well, it would be 400 feet, correct? So the area here equals 0.785 times 400 times 400. All right, which I do believe it's 125,600, but we're going to double check that. 125,600 square feet. Okay. Before I move on with doing the circumference, I want to talk about something real quick. The standard isolation area of a municipal well is 200 feet in all directions from any source of contamination. The standard isolation area of a municipal well is 200 feet in all directions from any source of contamination. Just so you know, this is a Public Act 399 of 1976. Does anyone know what that Public Act is? The Safe Drinking Water Act. Okay. This is a Safe Drinking Water Act question. All right. The standard isolation area of a municipal well is 200 feet in all directions from any source of contamination. And there's actually two more rules that go with this. There is from a minor source, keyword being minor. How many feet do you think a minor source is? I'll let everyone guess amongst themselves, 50, 75, 100. How about 200 feet? Okay. And then from a major source. So major sources of contamination are like a dump, a chemical dumping site that is known, like a brownfield development, or brownfield redevelopment, I think it's called, like a leaking underground storage tank, that kind of stuff. A major source of contamination, it would be 2,000 feet. So I'll leave that up on screen for a second so that you guys can all get that written down. There's keywords to look for here: minor, major, and any. Well, any and minor are 200 feet in all directions. They're the same, but major is different. It's 2,000 feet. Like I said, these are brownfield developments, large scale agriculture, like, a giant cow farm or pig farm, something like that. Because I know those do exist, giant chicken farms, stuff like that. Leaking underground storage tank. So if there's a old abandoned gas station in the area that was there from like the 50s, chances are it's got leaking underground storage tanks and stuff like that. So hydrogeo models are needed to see where that plume of stuff may be moving. Okay, so now that everyone should have those written down, let's go ahead and move up here to the next thing. What is the circumference of the well isolation area noted in problem 2? Okay, so it's asking what's the circumference around my really horrible drawn circle here, okay? Imagine it's the best circle you've ever seen in your life, right? It's perfect. There's nothing wrong with it. So what is the isolation area? So if you remember, circumference equals pi times the diameter, which is 3.14 times by 400 equals 1256 feet, 1,256 feet, all right? I apologize for my crap circle, but you know, I'm not an artist. I'm not even an engineer. I'm a scientist. I'm not even an engineer, so I guess I could probably draw better circles if I was. All right. Does that answer that?
Hey, Scott,
Yep.
I do have individual with their hand up. They also have a question in the chat.
Okay.
And this question is, how would I know to create a pie chart with question 2? I was clueless on how to go about the question. I never read this in any of my water books.
To create a, okay, so kind of something with this is you kind of got to make it a story problem in your own, okay? And we're going to see that especially with hydraulics tomorrow, is you kind of have to read the question and read what it's telling you, because it's telling you 200 feet in all directions, right? So that means that it's going to be like this, right? Like spokes on a wheel. It's going to be 200 feet literally in all directions. And those lines would being even, what shape would it make for you, you know? That's the best way I could tell you to figure that out. I wouldn't, I mean, I don't know how else to explain it, but you would have to think about it logically. It's 200 feet in all directions. So it's going to be kind of like all directions, right? You know, yeah, I don't know how else to explain it other than that, with a circle. Okay. I will tell you that, I don't want to say this is a trick question, but it's a logic type question, I would suspect. But most of them on the exam will tell you when you're dealing with things, if that makes sense. It'll tell you, you know, it's a 12-inch, 1,000-foot water main or something along those lines. The storage tank is, you know, 25 foot in diameter and 15 foot tall or something like that. You won't run across maybe 1 or 2 questions like this ever on an exam, if you ever do, to be honest with you. Most of them give you the outright diameter of stuff like that, okay? This question is a logic question to try to get you thinking, but it's also a question that introduces you to 3 different rules in the Safe Drinking Water Act too, okay? It sets the stage for me to give you that information. I hope that helps. I don't know how else to answer that question.
Yeah, I think, with story problems in general, and we had someone submit a comment, I thought the same thing as diameter and length. But sometimes story problems, and you know this, Scott, obviously, because you do these all the time, but trying to visualize a picture of what that problem looks like and then start lining up where your numbers are going to go.
Yeah. So I will just say that, you know, majority of what you will see on a test won't be a trick like this, okay? I know you've probably heard otherwise, and I guarantee you've heard otherwise, but most of the exam questions, I will say 99% of them are not set up to trick you. We give you the information you need, but you need to know how to do the math like 100% correct. Because if there's something where you messed up, you know, like especially on a chlorine calculation, which we'll see in a couple days, where you know you divided where you should have multiplied or something along those lines, well, I can guarantee you that answer will be on there. I hate to say it, but it would be. But this question is you got to try to visualize it type question. But I will tell you, there's not many on a test where we don't just give you the outright diameter, if that makes sense. Okay. Okay, so with that, we're coming into volumes here as our next stage. And I think what I'm gonna do is I'm gonna go ahead and do our 10-minute break now for areas and volumes. And then we'll go from there, okay? So I want to go ahead and take our 10-minute break. I will see you all back here at 9:41. Make sure you're back because we have a poll question to do. And we'll see you guys in 10 minutes from now. All right, well, it is 9:41. So all the participants should start getting back here. Before everything, I go ahead and share my screen again. All right, well, there's that. So we should be getting back. So I'm going to ask Matt to go ahead and launch a second poll question so we can get that rolling and get that out of the way, so to speak, with our with everyone.
Okay, this is just a simple yes, no question. Did you attend session 1? So if you want to take a moment to complete that question.
Looked over the participant list of people who have participating for attendees and noticed a couple names that I recognize from some of the exam apps that I've been working on the last week. Since 84% of you, whatever, something like that, yesterday indicated that you'll be taking exams, I just want to give everyone a heads up that on this call that we expect the letters to be going out at the end of the first week of October. So somewhere around like October 7th is when we're planning to let the letters hit the mail, so to speak. So those are going to be coming up. Don't be worried and call us in a frant of where's my letter. They haven't gone out yet, but because we are wrapping up the last like 100 applications in the next couple days as we speak. So we're getting there. I just it's a cumbersome process. The scoring of exam apps is not something that is very easily done. So it definitely takes a while.
And for those of you looking for the poll, if you click on the little camera in your toolbar at the bottom of your screen, that'll make Zoom your primary window. And again, if you're having issues with the poll question, please submit a question in the QA and let us know. And we will look at that in our closeout reports. So doing pretty good. 94% of those that are in attendance have responded.
I
And
noticed someone's name is Samsung something. The attendee.
yeah, I'm not sure how we will match that one up, but we will try.
Yeah, someone should definitely, whoever that is, it's I'm assuming on a tablet or a cell phone, should at least send in the comment and be like, yeah, that's me, because there's someone named in the chat or something. There's someone named Samsung something another. So if it would probably be helpful if you chatted us your name so we at least know who you are. So
Yeah, and you make a good point, Scott. With these courses in Zoom, we're trying to connect you with your operator ID and your organization. So the redundancy of registering, you sign up for the course, but then you come into a Zoom session, you click on register and you give us your credentials so that we can accurately award continuing education credit to those that wish to get it. So it's just something that'll be a practice moving forward. We know virtual training is not going away. We know it's efficient and gives you more time on your end to do what you need to do. So I'm going to go ahead and close this poll. And Scott, we've got about 94% that did attend session 1, 6% that this is their first session today.
yeah, that's the thing in the question. That's something, Matt, you guys got to follow up with. I've been seeing that over and over.
Yep. Understood. And we will be addressing that.
Okay. All right. Okay, so we're going to be going over the calculations of volumes, and yeah, I was say, Matt, I don't even really care if you put session 3 in the chat today for tomorrow. I don't give a crap. That's up to you if you want to, but all right. Just so you know that I'm okay with that. So
Yeah, I can do that. I can drop in session 3 and session 4.
yeah, so what we'll do, guys, is Matt will put session 3 and 4 in the chat so that maybe we'll give you guys a couple extra minutes at the end to like open it and save it or something before we close out, all right, of the thing, so that you can still see it and grab it, and then you can print it for the next couple of days if you're here, okay? So a figure in So the calculation of volumes, all right? So volumes is very similar to areas, but it's a little bit different, all right? Because, we talked about how we would recognize, I'm sorry, let me get that white square out of the way here. We talked about how we would recognize the difference or the type of unit by looking at what we're given to determine it's an area or so on and so forth, right? So with area, we were looking for things that were squared, right? Anything that's squared is considered an area. It's because it's the flat shape of things, all right? So now we're going to start talking about volumes. And with volumes, how you will know you're looking at volumes is no, not by the term gallon. Do I agree that gallon is a volume? Yeah, absolutely. It is a term for volume. But what you're going to start looking is you're going to start to notice these threes on stuff, kind of like this, right? And I'll even tell you, I was teaching in Chicago one time, and they said, "We need you to teach us." And I was like, "You need me to teach you miles cubed for real?" I was like, "You got to be kidding me." That's because Chicago's just that big, man. They have that much water, especially on the wastewater side of things. So when a big rainfall event happens and stuff like that, they get a lot of water. I mean, they get to the billions of gallons of water when that happens. So I was like a little shocked when they're like, "We want to know miles cubed." I was like, "Okay," but you can see what these all have in common here. They have the three, which means cubic. Okay, cubic. If you recall, 1 cubic foot equals 7.48 gallons. So cubic is a volume, isn't it? Because we know that gallon term is a volume. Also is cubic. So cubic feet is the same as saying feet times feet times feet, okay? So it's the same as saying feet times feet times feet or feet times 3 times. Okay, so now the very first thing we're going to be talking about volume in is a rectangular prism, okay? But I want to first point out what is this? Length times width. What was that? Well, that was the area of a rectangle, right? So the area of a rectangle is also in the formula for the volume of a rectangular prism. A rectangular prism is nothing different than what I like to call them boxes, to be honest. I mean, if you think about it, an Amazon box or whatever, because it's what we're familiar with, it's a rectangular prism, isn't it? You can put a certain, well, if it would hold water, you could put water in it, and it would only hold a certain amount based on its measurements. So with knowing that, I will most likely be referring to rectangular prisms as boxes, okay, just because what they are. So it's length times width times a third measurement, which in this case, it's height, all right? So here in this very first example, it says, calculate the volume of the tank in the following dimensions. It's 34 feet long, 14 feet wide, and 11 feet deep or high. 11 has a height of 11 feet. So yes, it is 34 times 14 times 11. 34 times 14 times 11, which gives me 5236 cubic feet. This is feet, this is feet, and this is feet. Gives me cubic feet. So one thing I want to point out here is if I asked how many gallons this thing is what would we do? Well, over and over and over again, we have done like this, right? 1 cubic foot equals 7.48 goes up here. So to go cubic feet to gallons, because that's what's left, we have multiplied by 7.48 every time, right? So I'll multiply that by 7.48, and that gives me 39,165.28 gallons. So my point is what? So we're going to see calculations here very shortly where the thing's going to ask for just gallons. And to get cubic feet to gallons, all we do is we multiply 7.48 and we get our answer, okay? And I will show you what the significance of that is shortly. But one thing I want to indicate here, in this calculation, we use the word height. Well, I can tell you right now that height is not always going to be the word that is used. Sometimes it could be high, tall, depth, or as we saw in this question, height. You will see all these terminologies in reference to the different types of measurement, which is the third measurement. So when you see a question that says 1, 2, and 3 measurements, it is a box or a rectangular prism, whatever you want to call it, okay? So it is length times width times height in these types of equations. So that's how to identify, are you dealing with a box or what we're about to talk about, which is a cylinder. The key is there's 3 measurements. There has to be in order to figure it out, all right? So the next thing we're going to talk about is the volume of a cylinder. All right, first off, I'm going to cross out all this baloney here. And what is this here? Just that part. That's the area of a circle, isn't it? 0.785 times diameter squared times the height. So just like in the rectangular prism, height can be referred to as height, tall, high, depth, or long, length, run, and stretch. Why would it be these 4 terms? Well, oh, sorry, I couldn't see that there. Why would I say long, length, run, and stretch? Well, it could be would you agree that this pipe is, so long? Or it's that length of pipe? Absolutely. So that's why it's long, length, or stretch, is because the fact that these are different lengths. So that's why, okay? So with that being said, let's go ahead and move to this question here. A chemical solution barrel is 4 feet high, has a diameter of 3 feet. How many gallons of solution will? Well, look at this. The question is asking how many gallons will hold. All right, first off, let's just do the first part of this thing, and then I'm going to explain what we're going to do here, okay? So the volume of a cylinder is 0.785 times the diameter times it's 4 feet high. But the question is asking how many gallons of solution will the barrel hold, right? Well, if we do the volume formula, we have feet times feet times feet. So this would give us feet cubed, right? On the last page, how did we decide you go from cubic feet to gallons? Like if I told you have 2 cubic feet, how many gallons is it? Well, you mind 2 times 7.48 gallons, right? So could I just times this by 7.48 like this to go to gallons? Yeah, you can. You can add 7.48 into this because all of this multiplied together is going to give you the same answer. So you're going to do 0.785, right? Times 3 times 3 times 4 times 7.48. And the great thing about this calculator is you can see everything you typed in, right? Everything looks right to me. Hit the equal sign and I get 211.38 gallons. So you can see that in one step instead of 2, I got my answer. The question didn't ask for cubic feet, it just asked for straight up gallons. So by adding that 748 up here to this calculation, at the end of it, like right here, I converted it from cubic feet to gallons. And you get a 211.38 gallons. So that measurement is very accurate because it's no rounding period. It's just right to the point. All right. And this is how one of the shortcuts that I'm going to show you that we're going to be moving forward. So what we're going to do is we're going to be paying attention to what the question's asking for, because if it's asking for gallons, we'll add 748. Well, what happens if this thing asks for pounds? What would we do? Well, if you have, 2 gallons of water, how do you get gallons to pounds? Well, If you think about it, it's 1 gallon over 8.34 pounds like this. So you're just multiplying the gallons by 8.34. So you could also add that in there to be 1 step instead of 2. So as you can see with rounding, if you continue to round and continue to round, your answer becomes less accurate because if you remember, we got 211.38 gallons. If we do it the rounding way, we come out to 209. And the thing is it's best to round least, like round at the end if you can, like that. With that equation, we put it all in one thing and you just rounded because it was all done calculation wise in 1 step. Okay. There's only these 3 sample problems, right? Yes. Okay. There are 3 sample problems here that I'm going to give you guys like 10 minutes to try on your own. And then, not 10 minutes. We'll give you 8 minutes to do these, and then we'll come back and do these together, okay? So I will see you at 10:06, right? 10:05. Okay. So go ahead, 8 minutes. Give these a go. All right. So how did we do? All right. So what is the volume of the tank? 25 feet long, 20 feet wide, and 10 feet deep. So this comes, oh, I got a question. Is it something about this stuff? How did you determine today's answers? Okay, so the 209, this is, this book was reviewed by an engineer, and what they were doing is they're dropping off the two, if you look back, they're dropping off the 2 decimal places here, and that's not what I told, oh, hold on, let me close that, you can't see that. They're rounding off, and they're dropping the 2 decimal places here. And I wouldn't have dropped that anyway. So even with doing it in one calculation here, remember I told you yesterday to keep 2 decimal places. So even if we kept this, if you multiply this by 7.48, you're going to get that same answer of 211.38, okay? So as you're going through and doing your math, if you're rounding because you're doing it in multiple steps, you still need to keep 2 decimal places, okay? Because if not, the more and more and more you round after more and more steps, the more inaccurate it becomes. And my point proven, this was done by an engineer, okay? This is why I don't just, I do the math on examples. I don't just, oh, here's the answer. If you've noticed, almost every one of my answers versus the examples have been slightly different. And that's because I went through and updated this book. I'm not the full author of this book. There are certain pieces that are authored by me and certain pieces that were authored by others. But that's why with teaching you, I've taught you 2 decimal places, because if you do that, like I'm saying, 28.26 times 7.48, look, get the same answer that I showed you. Because my point is proven, it's not good to keep off decimal places. Anything beyond 2 doesn't affect it that much, but that's why we go to 2. That's why I've told you 2 decimal places as you work through your math, because as you go to 28 and then you round it, you ended up with 209. And in today's world, with inflation being the way it is, if this is really what they gave you, 209, or, but you paid for 211 and you get 209, well, I mean, you could have got ripped off for 20 or $30 or even more, depending upon what it is, right? So with rounding, it's always keep it to 2 decimal places. So even if I wouldn't have done this in one step like here, I would have kept it at this, which gives you the same answer, right? I showed you that here.
So
Okay.
Scott, when you have that in the calculator like that, and your answer is 211.38.48. And so when you're looking at those first 2 decimal points, 0.38, and then you look at that next number and that's a 4.
Right.
So that tells you to leave it at 0.38.
That's correct. So like 211.38. The third number is the one we have to look at. With this calculation on this example, you only get 0.26. You don't get a bunch of other numbers behind it anyway. But I would have left it as 28.26. I wouldn't have left it as, and that's why I showed you here versus there. That's why you're using that as an example. But that's because I'm not the author of this book. And well, I'm like a co-author. I went through, edited things. But that's why I always work out every example with you guys on this stuff, is to show you this is the way it should be done, because it's more accurate.
I do have somebody with their hand up.
It is too late, James, by the way. Okay.
Oh, yeah, so a question for the application deadline.
It was September 6th was the application deadline for those, unfortunately. Sorry. Yeah.
Do you want to take a live question?
Yeah, sure. I don't care.
Okay. Mark Neely, if you want to unmute your mic, you can ask your question in person. So I have unmuted you on, there you go.
Yeah. So can you hear me?
Yes.
So utilizing your 2 step with the decimal, will there ever be a problem occurring on the test with that?
No. So I'm going to tell you, because that's one thing I pointed out yesterday. Okay. So first off, if, like if we go back to this example here, the 2081, this one, or even if we just say the question asked, how many gallons is it, right? If it was an A, B, C, D question, it would not be 211.38, 209, 207 and 210, right? We don't do that on the test. So first off, that answer wouldn't be there. This is too close and that's too close, okay? But what we would do is like one of the answers here, because you see how this has 3 times 4. What we would most likely put there would be like 3 times 3 times 4. And then if we did that times 7.48, you see how it gives the 269? Because you forgot we would have forgot the 0.785. So this is where like the wrong answers on the test come from, okay? And then I would do 3 times 3 times 4 times 8.34, because that's a common one. So it'd be like 300.24. And then I'd probably do 3 times 3 times 4 just because, and then 36. So that's how the answers for the wrong on the test are. We do not go through and round them and then put those as separate answers on the test, okay? Anyone who tells you that that's the case is wrong. So if you say you rounded and you got 209, but these would be your answer choices on the test, which one would you choose? Well, you're going to choose the one that's closest to yours, which is 211. Does that make sense?
Yeah.
Okay. I promise you, I'm the guy who writes the tests. Okay. Just so you know, I write most of the examinations. I also review all the math questions that are on all the other exams that I don't write. And any that are really, really close due to a rounding thing, we completely rewrite the question so that doesn't occur on a test. Okay. I just want to make that clear. A lot of people think that we're there to trick you, and anyone who tells you that, I'm going to tell you is full of baloney, because that is not not true at all. I just showed you like what we would do to get the wrong answers here. You know what I'm saying? So
Okay.
I just want to point that out. That is not, it isn't on a test. The wrong answer will never be because of a rounding thing. I promise you that. All right. It would be because you didn't do the math right. Does that make sense?
Yeah.
Yeah, and I already asked James's question. Yeah, sorry, James, too late. Okay, so with that out of the way, let's go ahead and get these questions through, okay? I hope that clears up with the rounding thing. That's why I try to stay as consistent as I can. And like, you'll see it on this test or on these questions real quick, like how I do it, okay? To stay consistent with it. So what is the volume of a tank that's so 20 feet wide, 10 feet high? So it is 10 feet tall, 25 feet long. So what shape do I have here? First off, I saw that there's no crap. I messed that up. It was drawn really good. And then it's 25 this way. So I've seen 1, 2, 3 measurements. This told me that this is you can call it a rectangle. I call them boxes, whatever. It's a box. It's a rectangular prism. Well, the volume formula for that, when I have 3 measurements like that, is length times width times height. Well, in this case, it's depth. All right. So we're going to be doing 25 times 20 times 10, which is 200 times 25. 5,000 cubic. Okay, this is a bad example. This one doesn't have decimals. This is 5,000 cubic feet, right? So that's cubic feet. Now, how do I get cubic feet to gallons? We already talked about this. Cubic feet to gallons, you just multiply by 7.48, okay? Yeah, okay, this has no decimals at all. So this is 37,400 gallons, okay. Well, obviously this one was a crappy example of that. All right, what is the volume of a cylinder? Okay, so it's 9 feet in diameter and it's 15 foot high, right? So this is 9 foot this way and this is 15. The volume per cylinder, if you recall, is 0.785 times diameter times the height or depth. In this case, it's high. So it's 0.785 times 9 times 9 times 15. This is 0.785 times 9 times 9 times 15. Now you can see here, I got a decimal, okay? So my decimal on this, I'm going to do, it's going to be 953 point. So second decimal here, round up, because you see it's the 5 and up, you round up. So this is going to be 7.8 cubic feet. Now I need to get that to gallons. So I'm going to times this by 7.48. Which is going to equal 7,134.27. Again, I have decimals here. You see the 4 here. Well, I'm going to leave those off because they're 4 and under. So, you know, the thing is I think one of the comments about the rounding was they noticed in the answer keys thing were a little bit rounded off, a little bit differently on each, and that's just you know, the answer keys are old and they were kind of rushed to get done. But the answers are really close. I mean, even by being, you know, 0.66 on an 8-inch versus 0.67, it changes the answer by like 0.2. It doesn't change it by like hundreds or anything like that. Okay. All right. So now this question is a little bit different. This said, because I had to do on these both cubic feet and gallons. This question is just straight up asking how many gallons here. Okay. So how many gallons of water will a water main hold that is 18 inches in diameter and 1,500 feet long? So it's a pipe. All right. So the first thing to do to inches is convert them to feet. So 18 divided by 12 equals 1.5 feet. And the reason for this is because it's asking, remember I told you with units, they all have to be the same in order to do the calculation. Well, in here I have 18 and 18 inches and 1,500 feet long. So I could promise you, I think it was Mark Neely, is that it, who was just speaking? Mr. Neely, if you didn't convert this, one of the answers on the test would be based on 18 inches and 18 inches. All right. I promise you it will be. All right. That's how the math questions are done. I can promise you it would show up as an ABCD answer. So we need to make sure that we convert it to feet. So the volume formula is 0.785 times my diameter times 1,500. This question is asking for how many gallons right off the shoe, right? It's not asking for cubic feet and gallons. Well, how do you go from cubic feet to gallons? Remember, volume gives you cubic feet. Well, how do we get cubic feet to gallons? So this, if I stop here, is cubic feet, but I want it to gallons. So you multiply by the 7.48. This answer will be the most accurate answer you can get because the fact there is no rounding period until the very end on this one. So 19,817 point, what do you think? What would we be? Point what? .33 gallons. And to prove my point a little bit here, to show you that it wouldn't be too awfully different, 1.5 times 1.5 times 1,500. So I'd round that to 3.8. So 2649.38 times my 7.48. You see how little of a difference there is there? 0.33, 0.36. I mean, that
So
is,
Scott, with that third digit being a 5, that's your determining factor. 5 or above, you round up.
yep, 5 or
Or
above, you round up. That's absolutely. But I was just showing if you did this in 2 steps where you do that, round, and then multiply by 7. Look, I mean, look at the difference. It's 0.03. That is such a small difference that we would never, ever put that on a test, ever. All right. And if you don't, I will buy you lunch. I promise you. Okay. You won't ever see that on a test. I promise.
So we have a comment in here. Is number 6 an example of when you would use inches for an S3 or S4 exam?
No. Yeah, well, it's an example, but you never use inches for a 3 or 4. You see how I converted it to feet? like I did here. So yes, this would be an example of what you may see on a 3 or 4, but I converted because it's asking for gallons, so it has to be in feet. All right. I don't have any examples of the ones you don't convert. Okay, so mark my word, if you're taking a 3 or 4 level exam, you always convert inches to feet. There is no exceptions to that rule, okay? So I don't know who the comments by, but I just want that to be known. If you're taking a 3 or 4 level exam, you always convert your inches to feet, okay? And you divide by 12. I promise you that is 100% true. Okay. So the problems here are homework, but there's one I want to go over first. It's on page 36 here. It's called bonus question, all right? I want to explain this one to you because it hasn't been explained in any of our notes. And it's one of those thinking type questions. And this will just help you with understanding some stuff that we'll be doing tomorrow anyway. So I think, or is it today? Pretty sure it's tomorrow. Hold on, let me look. Maybe I'm lying to you. Yeah, it's tomorrow. I'm not lying to you. Okay. All right. An empty storage tank measures 95 feet long, 25 feet wide, 18 feet deep. If 211,900 gallons are pumped into the tank, how high will the water level rise? Okay, so first off, I like to draw pictures for this stuff because it helps people understand what we're dealing with here. Someone just fell down outside my room and went boom. Okay, so would you agree that it's something like this shape, right? I mean, obviously we went with the lowest bid, so that's why this back wall is a little janky, but you know. So it's a box. It is empty, but we're saying we're going to put water in this thing. And we want to know how high it's going to rise, right? We don't know this is what we're looking for. So I need to know the total volume of this box first. Are we even going to fill it? Or are we going to overfill it possibly? Well, I wouldn't know unless I know how many gallons this box is. So I want to know how many gallons it is. So it's 95 times 25 times 18. That's the volume. Well, how do you get it to gallons? Multiply by 7.48. Get my mouse out of the way, sorry. 95 times 25 times 18 times 7.48 is going to give me 319,770 gallons. Okay, so I didn't overfill the tank. But what I want to impress upon you, right? Think about, you know, this crap example, but yeah, I don't know. Does this actually work? I've never tried. Is that upside down? Sort of. See, this is my Gatorade bottle. So if I fill this thing with water, what's the only thing it ever changes? Does it go up and down, or does the surface area of it expand this way? As you fill anything, the only thing it ever changes is what? The height, okay? So my point of that is, if we fill this box with water, what's the only thing it's ever going to change? Is the shape of the floor going to change, or is it going to be the depth as it goes up and down as you're filling it or lowering it? The only thing that's ever going to change is the height, correct? So I asked this question before to people and it seemed to sink in. Let's say the wall is 10 foot. You have a 10-foot wall here, right? That's deep. It's 10 foot deep. If it is, say, 75% full, what height is it? Like, where would it be on that 10-foot wall? Well, it would be 7.5 feet. Doesn't that make sense? Because that's 75% of 10 foot. Okay, so what I'm getting at here is if I determine the percent full this tank is based on these two numbers, that's a percentage of my height or depth because that's the only thing it changes. Well, how do I do that? Well, do you remember yesterday's examples? If I have 211,900, I have part of the whole. The whole is 319,770. So what does that give you when you divide those two? 211,900 divided by 319,770. It gives me this decimal. So I'm going to go to the second decimal place here, and you see this is 4 and under, so I'm going to round that down. So it gives me 0.66 or 66% full. So that's 66% of the depth. So you multiply 66% or 0.66 times the 18, and you're going to get 11.88 feet. That's how high the water is in that tank. It's 11.88 feet. And it's all just based on percent full, because the only thing it ever changes is the depth as you fill or lower the tank. Okay. This one, we're going to be doing a couple like this tomorrow. So that's why I'm stopping going over this, so that tomorrow when you see the question, it might, jog your memory a little bit on what to do. Okay. Does everyone got that thing? This is one other thing about, I don't know if everyone has it done or not. So I'll leave it up for a second. All right. Now we're going to talk about water velocities and flow rates. Okay. So first off, if any of you are bow hunters, velocity might make a little bit of sense to you. And if not, I'll explain it. So velocity is the movement per time of direction. And typically what I do is I'm going to draw my really crappy car. And it's going to go, I drew it backwards. Of course I did. My car is going this way backwards at 55 mph. Yeah, man. Okay, 65 mph. Might as well own up to it. So if it goes this way for 1 hour, how many miles is that going to be? Well, it's going to be 65, right? This is a velocity. Velocity is a direction with change over time. Okay. So we measure velocity of water in our water systems moving through the pipes in a different unit. We don't use miles per hour, so it would be an incredibly small number, but we do use feet per second. So what we're saying is that in 1 point, so if this is a pipe and it's 3 feet long, we're saying that every second the water moves 1.5 feet. So it would take the water 2 seconds to go that 3 foot. Does that make sense? That's what we're doing with velocity, as we're giving it a direction with change over time. So water velocities in pipes are not very fast very often, because if they are, the velocities increase pressures and blow apart pipes. We don't want that. But velocity is also used in the determination of a flow rate. So gallons per minute, million gallons per day, cubic feet per second, right? We've already seen some of these. These are flow rates. And flow rates are often referred to as the letter Q, okay? So we're going to be doing the letter Q, or the continuity equation, tomorrow. That's why I'm introducing the subject to you today. So flow rate can be lots of different things. It even could be pounds per day, because we know how to convert gallons to pounds. That one's pretty uncommon, but gallons per minute, million gallons per day, and cubic feet per second are the most common flow rates, right? But of course, like everything, we have to have a standard. The standard flow rate is cubic feet per second, or written out like this. The standard flow rate, that Q, is often referred to in water distribution as cubic feet per second. It is not gallons per minute, and it is not million gallons per day. It is cubic feet per second, okay? So here in this first example, I want to convert 700 gallons per minute to cubic feet per second. Well, I know that if minutes are on bottom, F be on top. 1 minute equals how many seconds? 60. And if gallons are on the top, where do they need to be to cancel? Well, down here, 7.40 gallons. or 1 cubic foot. So it's 700 divided by 448.8. Oh, whoever it was that mentioned rounding stuff, then I said that I co-authored the book, meaning I made it updates and changed some stuff. This is where you're going to notice that the rounding is the way it should be, and that's because I wrote this part of the book. Okay. This is all me written by me. Okay. So, and you can see we got 1.56 cubic feet per, I forgot the second. All right. I'm gonna skip this one, okay? But I do want to go to this one because I'm gonna have you guys do 6 calculations before we call it a day. And I obviously didn't delete that part, but 0.1 million pounds per day to gallons per minute. Okay. So what this looks like, I want to give some explanation of this. This looks like 1.1 million pounds per 1 day. Here's that big M unit. Okay. That big M unit, if you have a unit with that, you cannot convert it first until you get rid of that. Okay. Because the conversion here throws everything off at that point, that M, the big M pounds. All right. In order to get rid of this big M, you need to multiply it by 1,000,000. That will eliminate that. Okay. And it will give you 100,000 pounds per day, like this. So in order to do a unit conversion with this big M, it could be 1,000,000 gallons per day. It could be 1,000,000 pounds. Those are the 2 places you see that unit. But in order to convert them, you need to get rid of that big M first, and you do it by multiplying by 1,000,000. Okay. So then we go 100,000 pounds per 1 day. We want to get that to gallons per minute. So 8.34 pounds on the bottom equals 1 gallon. Pounds cancel. 1 day on top, 24 hours. Because days on bottom is going to be on top, cancel. And then here, hours are on bottom, so they got to be up here with 60 minutes. So when I do the math, it'll be 100,000. Then I got to multiply all this stuff on the bottom, put under it. Hours cancel. 8.34 times 24 times 60 equals 12,009.6. And this comes, okay, 8.33 gallons per minute. Okay, so there is 8, 9, and through 13. I'm going to give you guys like 7 minutes to do these, and then we will go over these together. Yeah, I know it's more unit conversions, but there's a reason. Like I'm pounding unit conversions into your heads to hopefully that the repetition sticks. That makes sense. All right. So I'll give you 7 minutes. We'll come back, do them together, and then that'll be the end of the class. All right. Okay. So it has been about that time. Let's go ahead and walk through these together. All right. So the very first thing we have here is we have 450 FPM, which stands for, remember, write this out as you're going. So 450 feet per 1 minute. Now remember the per is the fraction bar on these splitting the units here. So 450 feet per minute. We need to get it to FPS, which is feet per second. So you can match that we have feet and feet, but I have minutes to seconds, so I have to convert this. So as we have done in the past, if minutes are on the bottom, where do minutes have to be to cancel? Well, minutes have to be on the bottom. They must be on the top to cancel. And what does 1 minute equal? Because that's what goes below it. That's what's attached to it. 60 seconds, right? So we cancel that out. Remember, you multiply everything across the top this way, everything across the bottom that way, and you're gonna get 450 over 60, because 450 times 1 times 60. Then we divide this at the end here, 420 divided 30. So 7.5 feet per second for that one, okay? Now let's do this next one. Now we have convert 7 CFS, so 7 cubic feet per second. Do either of my units match? I have cubic feet to gallons and then seconds to minutes. No, but I know that 1 cubic foot of water is 7.48 gallons, and I know that 1 minute equals 60 seconds, right? We all know this one. So with that being said here, we're going to have to convert both units. So I'm going to convert my cubic feet first. If cubic feet are on top, where do they need to be to cancel? Well, here. And if 1 cubic foot is on the bottom, what's attached to it in the conversion factor? The 7.48 gallons there. That cancels. Now, if seconds are on bottom, even though they're separated, where do they got to be to cancel? Bottom here, they need to be on the top there. And 1 minute here on the bottom. This will give you, cancel your seconds and give you gallons per minute. So now we're going to do the math here. And everything across top, because on the bottom we got 1 times 1 times 1, which equals nothing. So I got 3,141.6 gallons per minute. All right. So that's those two. Now we have these other four, I lied. Okay. I have 1,125 gallons per minute. I need to get it to gallons per day. So I don't have to convert gallons, but I got to get minutes to days. So how many minutes are in an hour? 60, 1 hour. Well, and there's 24 hours in 1 day. Kind of like that. If hours are on bottom, they have to be on top to cancel 1 day at the bottom here. So everything across the top. So 1,620,000 gallons per day. Okay. Convert 2,600 gallons per minute to cubic feet per second. 2,600 gallons per minute is what I'm starting with. All right, let's see if we can do this without writing our conversion factors out. Okay. If gallons are on top, where do they need to be to cancel? Well, they got to be here. And how many gallons is it to cubic feet? Because we got to get to cubic feet. So 7.48. And this is 1 cubic foot. I need to give more space on these. I need to add some spaces to this because this is even tight to write in. All right. but I gotta get minutes to seconds. Minutes are on the bottom here, so where do they need to be canceled? Up top. Well, I gotta get minutes to seconds. So 1 minute equals 60 seconds. So I multiply everything across the top, across the bottom here. And then I need my answer. Of 5.79 cubic feet per second. All right. The next one is 4,320,000 gallons per 1 day. And I got to get this to cubic feet per second. So if you look, this is gallons per minute to cubic feet per second, right? But I'm from day. So I'm going to do my first conversion because I got to get gallons to cubic feet, which is very similar to this. The gallons are up top. They have to be down below to cancel. 1 cubic foot up top. Now I got to get days to minutes. Some of you may know how many days, or you got to get days to hours, hours to minutes, minutes to seconds. Some of you may know how many minutes are in a day, but a lot of people don't. So I'm not going to go down that road of assuming that we know, and we're going to just stay here. All right. So I'm going to go with 1 day equals 24 hours. Okay, well, I got to get hours to minutes. So how many, if hours are on bottom, they have to be up here. So 1 hour, how many does that equal? It equals 60 minutes, right? The hours cancel. Well, I got to get minutes to seconds. And if 1 minute equals 60 seconds. So I got a lot to multiply here. It's 4,320,000 divided by all this multiplied together. This gives me 6.68 cubic feet per second. All right. And then I got one last one here. This one sort of looks like what we were talking about earlier. 2.9 million gallons a day. What do you need to do in order to convert this first with that big M unit? I did an example just before these 6 questions and showed you what to do. In order to convert this, you need to get rid of that big M. You do it by multiplying by million, which will give me 2,900,000 gallons per 1 day. Does this look any different than that now? It's not. It's the same. 7.48 gallons, 1 cubic foot here, times 1 day, 24 hours, 1 hour, 60 minutes, over 60 seconds. Just like that. So you get 2,900,000 over the 646,272. And I got 4.49 cubic feet per second. All right. So I'm hoping that unit conversions are starting to stick. I hope that areas and volumes were there too a little bit. But the way I got this book set up and the things that I've added and things I've done to this differently is to try to pound into your heads how to do unit conversions, okay? Because they're really important, especially on like the continuity equation, and especially when we get to doing chlorination.